Hi, my name is Tongyu Zhou, and I'll be presenting Filtered Ink, creating dynamic illustrations with SVG filters. This is work done in collaboration with Connie Liu, Joshua Kong Yang, and Jeff Huang at Brown University. So previous tools have demonstrated the expressiveness and potential of dynamic images. However, two challenges in the authoring processes of these illustrations remain. The first is that visual effects like animations are often added post hoc, which divides freehand drawing and their modifying effects and animations into separate processes. The second is that these tools often export raster-based files, meaning effects cannot be easily modified post-export without helper files from the tool. To target these two issues, we argue that a vector-based approach can better enhance expressivity by 1. Enabling the user to draw directly with shapes and effects, which better matches with how they think about drawing organically, and 2. Fully preserving tool-independent editing. This is possible as shapes, textures, and animations can be codified in vector, so you can take a texture animation applied to a shape, like these chi letters here, and reapply it to a different shape, like the star, easily. The codify effects also mean that edits can occur in any order instead of sequentially like it is in raster paradigms. And due to its vector nature, it also benefits from being pixel agnostic, so the drawn object can be scaled to any resolution without losing quality. Despite these positives, vector graphics are still not a very common output format in digital illustration and painting because creating detailed textures and animations in vector is not a trivial task. And while a couple of commercial tools in separate drawing and animation spaces have been created to help users author these effects, they don't fill the niche for dynamic illustration. Thus, our proposed tool, Filtered Ink, is at this intersection by enabling direct freehand drawing of textures and animations in a workflow where these effects are considered first-class objects. Filtered Ink relies on the idea of SVG filters, which is a graphical transformation applied to an SVG that is recomputed dynamically at each rendering resolution. These filters are composed of primitives, a total of which I've listed below, which each has their own tunable parameters that can be additionally animated. And by rearranging these primitives and parameters in different combinations, a user can create different visual effects. So I have an example here where the SVG on the left is a plain vector image, the one in the middle has 3 composited filters applied to the background, and the one on the right has 2 additional stacked filters applied to the foreground diamonds. So this is what it looks like on the interface. On the top bar, we have common functionalities you would see in any drawing tool. On the left, we have a panel for filter functionalities that contain a list of the currently active filters and ways to manipulate them. When the user clicks on the edit button for any filter, a dialog like this would appear. This dialog provides an abstraction for the underlying SVG filter code as shown on the left, and can be broken down into 3 essential parts. The first, indicated by A, is a list of primitives that make up that filter. We represent them as nodes in a node graph, where the active branch is highlighted in black. And this idea of an active branch harkens back to the stack-based nature of the filter code, where the filters on the bottom take precedence and reads inputs via a bottom-up approach. So in this figure on top, you can see that code bits A and B are inactive because C takes precedence and does not need an input. And on the bottom, you can see that clicking on an inactive branch sets that to active, which in the code means that the primitive is moved to the bottom of the stack. So B indicates the parameters for each filter primitive. And since each primitive has a different set of parameters, we try to use abstraction and direct manipulation whenever possible to make the parameter tuning process more intuitive. So in this particular example, we use a bipartite graph to represent the color matrix primitive values. C indicates the animation of the parameter values. We introduce a pop-up as shown here that separates the animation into looping states over these values, and users can then edit the values of each state using the interface in B to control the animation. Using these abstractions, the user can then combine sequences of filter primitives and tune their parameter values to create different animated visual effects. And then once they're done, they can upload it as a preset to share it with others. Similarly, they can also remix someone else's preset. They can then apply the filters to the brush to draw with them directly. To lower the learning curve of and enhance the breadth of expression for filter design, we support 3 types of remix through the system. First is remixing filter parameters. So you can see that you can create an aluminum foil effect from paper by increasing the surface height parameter of this primitive. Second is remixing filter primitives. So here you're adding a specular light primitive to create a concrete-like effect from a paper effect. And the last is remixing the filters applied to the drawn strokes. So changing the style of the drawing by replacing the pencil effect on the flower with a watercolor effect. And we see how combining different types of remix can result in a wide range of visual outcomes. And here are some examples of drawings the author created using the system using all three types of remix. Next, we then conducted a user study for filtered.ink to understand the natural workflow of how users are creating dynamic illustrations and to examine how filter usage may inform the styles of vector illustration. We recruited 9 participants who either create art professionally, for school, or for recreation. They mostly cited PNGs as their file format of choice, and while they have worked with SVGs before, mostly for web design, they have no prior experience with SVG filters. They were first introduced to the interface and shown the functionalities available on the platform. They then completed 2 tasks. The first is to select a filter they liked from a list of presets and then recreate it. The second is to incorporate filters into their drawing however they saw fit. And here I'm showing the resulting drawings from the second task. Some interesting things we saw was that without prompting, all participants incorporated some form of animated filters into their drawings. 2 of them relied on only presets, while the rest either created their own or remixed from existing ones. Some users use these filters to emphasize subjects in the drawing, like these tears, while others use them to emphasize background or environmental elements like clouds or bushes. We further summarize our observations of how participants interacted with the filters into a model for user workflow. This model is divided into 4 stages, which we described as see, want, rewant, and remix. So first, we found that users were motivated to explore and use the system by seeing immediately inspirational examples. And most of this inspiration was cited to come from painterly animated effects of the filters. Next, when initially wanting to create something, the artist relied on knowledge from prior mediums. So depending on their previous experience with traditional versus digital tools, their preferences for workflow changed accordingly. And as they further explored the system, they constructed new mental models. And what we saw in particular was that they developed new strategies for storytelling after interacting with effects like lighting as a first-class object. And finally, to actuate their new visions, users relied on remix at varying levels of complexity. And one interesting observation we made was that participants with high remix complexity were more likely to share their filters as presets for others to use. And the themes from these models can also be extrapolated to apply to other similar vector-based tools with some learning curve present. In summary, our contributions include a system for dynamic vector illustration that merges drawing and texturing/animation in a single brush metaphor to achieve expressive styles, as well as a user model for vector-based creative systems informed by a task-based user study on workflow patterns and affordances. I've also included the link for filtered.ink below if you want to try it out. Thank you for listening.